Welcome back to our webcast series on plane and descriptive geometry. In this video we're going to look at one of the most important principles that we're going to deal with, and that's the principle of how to locate a true length of a line. So we're going to begin with, first of all, by just looking at what a true length line actually is and what are the conditions that we need in order to see a true length line. So to begin with, a true length line is a line when viewed appears the same length as its actual true length. So if you were to take the example of a line or maybe a metal bar, well, if I was to take a measuring tape and measure that metal bar, the measurement that I get, if I look at the bar, if the distance that I see, the length that I see when I'm looking at the bar is the same as that measured distance, well then we are looking at the true length of it, or we have a view that is giving us the true length of our line. So in order to locate our true length line, we need to have two conditions. The first condition is a line appears as a true length when viewed looking straight at it. Graphically speaking, this means looking perpendicular to it or at 90 degrees to it. So if we look straight at a line, we'll see it as a true length. The opposite, I suppose, it can be considered as well, that if we look at a line that's angled towards us or away from us, well then it will appear shorter than what it actually is, and this is known as being foreshortened. So if you look perpendicular to the line, you see it as a true length. If the line isn't perpendicular, if it's angled towards us or away from us, then we won't see it as a true length, it will appear foreshortened. Our second condition is that the line that we're looking at must be parallel to the plane upon which it is projected. So anytime we take a view in our orthographic, we're projecting onto a plane, so like the vertical plane or an auxiliary plane or the horizontal plane. In order to see a true length, the plane must be parallel with the line that we're actually trying to find the true length of. So there are two conditions. What we're going to do here now is just take a look at an example of a true length line and try and explain maybe those conditions a little bit more. Okay, so here we can see the example that we're going to take. The example is of a person standing directly in front of a door. So here we have the front elevation of our person and our door. Here we have the plan view of the same person and the same door. Over here we have just a little 3D view just to help people kind of visualize what's going on. So the basic idea is that our person at the moment is standing directly in front of the door. So graphically speaking, we say he's standing perpendicular to the door, and from the front elevation you can see, if we look at the top edge here, the person is seeing the true length or the true width of the door, the true width of the door being the same width as the door frame at the moment. So if I was to go and open the door, for example, you can see as the door is opening, you can see the width of the door is getting smaller. So as the door opens outwards, it's no longer perpendicular to us, it's now angled towards us. So as the door is angled towards us, we're now seeing a foreshortened or a shorter version of the door itself. So, and this can continue right up to the point until eventually we don't see any width at all. We just see the edge as a single point view, and that's actually another principle of graphics, that if you look parallel to a line, you see the line as a point view. So that's, I suppose, the most extreme version of our foreshortening. So if we were to close the door, again you can see as the door closes it starts to get larger until eventually we're looking straight at it again, perpendicular to it, and we come back to seeing it as a true length. So that's the basic idea of our true length in action, really. What we're going to do next then is just take a couple of examples more in line with what you're going to see on your, say, your sheets, to try and familiarize you with it. Okay, so from our example there, we saw that if the door is directly in front of us, i.e. perpendicular in front of us, we see the true width of the door, and how if the door is angled towards us, we'll see it foreshortened, so we won't see the true length or the true width of our door. So what we're going to do here is we're going to take a number of examples, but present them more in line with what you're going to see on your sheet. So we're just going to break it down to a single line in this case, so in elevation A1, B1, in plan view AB, and we're going to first of all see how to recognize, do we have a true length line or have we got a foreshortened line? So in this example here we have a pretty straightforward thing. We can see in elevation the line is horizontal, in plan view the line is also horizontal. So are our lines true length or not? Well, all we need to do is ask ourselves, when I look at the line, am I looking perpendicular to it? And likewise, our second check is the line parallel with the plane that we're projecting it onto? So starting off here, we can see if we look from plan view straight in at the object, well, we are in actual fact looking perpendicular to it. So we know that when we look in from our plan view straight in at that, that's what gives us our front elevation here. So in actual fact, yes, it is going to be a true length line. So we can see that's projected onto our vertical plane here and giving us our true length line. The same thing applies when it comes from looking from above. When we look from above, again, this is what gives us our plan view. So we can see we are actually in actual fact looking straight down at the line. The line is parallel with the XY line, so it's parallel with the plane we're projecting it onto. So it meets our two conditions, and that means that when projected down to give us our plan view, we have a true length line. So in both these views, in this case, we are dealing with a true length line. So our next example then is an example where in the plan view our line is horizontal. In the elevation though, our line is angled like so. So again, we apply the same basic theory. So if we're looking straight in front at our object in our plan view, we are looking perpendicular to it. So when it's projected onto our plane, our x1, y1, or our vertical plane, we can see that it is parallel to it, which means that in elevation we have a true length line. Now let's do the exact same thing from above. From above, we can see that we're not looking at it perpendicular, and likewise our line isn't parallel with the xy line, so it's not parallel with the plane it's been projected onto. So therefore what we're dealing with is a foreshortened length in plan view. So we're going to take the exact same thing then, only this time it's going to be horizontal in elevation, it's going to be angled in plan view, and we can see that as we look in from the front of our object, this time it's not going to be perpendicular to us, it's not parallel with the xy line, so when we project it onto the plane, our front elevation is going to be foreshortened. Likewise, looking from above this time, we can see that, well, actually yes, we are perpendicular to the line. The line is parallel with the xy line, so therefore when we project it onto our plane, it's going to be given as a true length line. So in each of those cases there, in at least one of our views, we've had our true length line. So hopefully you'll be able to recognize how we know whether we have a true length line or not. In this next example here then, here we have a case where our line is actually angled in elevation and in plan view. So no matter what direction we look at, if we look from above and project it down, we have a foreshortened length in plan view. Likewise, if we look from plan straight in at our object, well, we have a foreshortened length in our front elevation. So neither of our two main views here give us the true length line. So if that's the case, and you want to go and find the true length line, well, you have two options when it comes to finding it. The most basic, I suppose, of those options is that if you were standing here and looking in, and we're not looking in at the object, the line itself is angled towards us, well, you can just change the position that you're looking in at it. So instead of standing here and looking straight in this direction, what we can do is we can move ourselves over to this direction here and make sure that we're looking perpendicular to it. So now if we look in from this direction, we're looking in perpendicular to it, so we're going to project an auxiliary view guaranteeing is the true length of our line. So if we're looking in perpendicular to it like so, we're going to create an x1, y1 line that's going to be parallel with the line. That was our second condition. So there's our x1 line in plan view. That represents this auxiliary plane here in our 3D view. And what we're doing is we're projecting our line onto the auxiliary plane. So there's our lines been projected on. How far do we go? Well, because we're just walking around the object, we can take our heights from our front elevation. So there's our h1 there. There's h1 there, giving us b2, and there's h2, the height of our a, and there's a2 there. So there is our line drawn in our auxiliary. Because we're now looking straight in at it, well, it is going to give us a true length line. So that's one method to find the true length of our line. The second method we're going to do is just as simple, and it's a case of instead of walking around the object and moving ourselves, what we're going to do is we're going to move the object. So in the same way that opening and closing the door was changing the length of the door, we're going to rotate this line so that we're no longer looking at it skewed. So first thing I'm going to do is just going to draw in my hinge line here in my 3D drawing. So here's my 3D of my line. We can see the hinge line is going to be vertical. It's going to be seen as a point in plan view. There it is in our 2D view, vertical. There it is as a point. So that's the point that we're going to use as our hinge. So if that was our door, well, there's the hinge for our door. What we want to do is rotate that line so that we're now looking straight in at it. You can see as we rotate the line, the height of our bottom point here stays the same. You can see it hasn't dropped. It just continues to move perpendicular at 90 degrees to the hinge. So it hasn't dropped any height and just rotates around like so. In our drawing, how do we actually do that? Well, what we do is we draw a level line, so parallel with the XY line, because that's what it needs to be a true length. And using our hinge point, we just swing point B around, giving us the new position for B. So we bring that straight up into elevation. That's going to be where the line stops. Because it doesn't drop any height as it swings around, we can just continue point B straight out like so, giving us the new position of it and our true length. So that's a second method to find the true length of our line. So they're two very, very useful ways to locate the true length of our line. The last thing we're going to do in the video is just show a simple example of where might you actually use this. So two examples are one for, say, developing an object. If we want to flatten out, say, the likes of a square-based pyramid here like that, well, we need to have the true lengths of all sides. So if I wanted to, say, find the true length of OC, we could use our rebattement method, our swinging around method, like we saw there, and that can locate us the true length of that edge, and then we can use that to string an arc and locate the true length and the development of the object. So very useful for that. Another example there would be if you were to, say, take the example of maybe a roof. If you want to have a hip of a roof like so, and you wanted to locate, well, the true length of that, well, you could just look in and take the true length of it from our auxiliary there. So either method we'll use, and in fact you can, whether you use the auxiliary method or the rebattement method, it doesn't actually make any difference. Whichever you're the most comfortable with, both will give you the true length of the line that you're looking for. So that ends our video on true length lines. Hopefully it's been of some use to you, and if you have any questions or queries, you can post things up on the website. So thank you very much.